have your math brains on?
We'll see.
Okay, before I introduce Garland to all of you, I wanted to set a little bit of a frame for us for the hour that we have together. If you are a parent of a third grader, would you raise your hand?
Woo.
All right, thank you. Parent of a fourth grader. Parent of a fifth grader. Parent of a sixth grader. Parents of a grader other than that. Okay, very good. Welcome. We are thrilled to have you here. And what I love is when we think about math, that's where parents tend to go, they do it so differently than I did when I was little, right? Well, that's a good, wonderful, fabulous thing, and we're going to explain why in this hour with you. But I wanted to give a little bit of a lens for you, a little bit of a frame. Remember that story in the Bible that talks about building a house on a solid foundation? So if the house is built on sand, what happens?
Collapses.
The sand erodes and the house crumbles. But if the house is built on a solid rock, what happens to the house?
It lasts.
It lasts. It lasts, absolutely.
Hopefully for an eternity.
Hopefully for eternity, that is true. So, I want you to think about the way that your child is learning math now. Even though it looks very different than what you did, the purpose, our mission, is to help them have a strong conceptualization of why they're doing what they're doing. When we were in school, we learned how. Do this step, do this step, do this step, memorize it, boom, you're done. Right? Well, guess what? That's sand. And so many of us grew up either saying, I'm a math person, or I'm not a math person. Everyone raise your right hand. Raise your right hand. I promise to never say I'm not a math person in front of my child. All right, let's try again. I promise to no longer say. Okay, excellent. So what we're going to do today is start helping you understand the solid rock that we're providing your children by the way we're teaching that. And then also, so that you, when they're doing something at home, you have a little bit of an understanding of what they're doing. You have wonderful teachers that are not only in this space here, but also at Mount Vernon. If you ever have a question about why in the world your child is doing it that way, ask, and we'll be happy to share with you. Now, we are blessed at Mount Vernon to have Garland Linkenhoger with us as our math consultant. She has an abundance, I'll use another adjective this time, she has an abundance of years of experience and expertise in working with children, not only little bitties, all the way through high school, college as well. So that's a heck of a lot of years of a span. And what she can very easily do is say, the reason we're doing this in third grade is so this happens in college. Okay? So without any further ado, you need all of the time that you
do.
have.
Well, we all need all of it. Okay,
right.
Thank you. It's so good to see you. Good morning and welcome. For those of you who came back after last Friday, I'm so happy that you came back and that you were excited to learn about 2 other operations. For those of you who are joining us for the first time, I welcome your questions. I welcome your stopping if you need clarification, if you want another example. Just let me know, and I'll do my best to try to help. There is a crowd, and whenever I ask students to do something, I try to monitor it very carefully that we're all on the right track. I can't promise I'll get to every single table, every single question. However, I have people who are willing to help me out and kind of give me a signal. If y'all will give me a signal, that's even better, because then I know specifically who might want to have a conversation or a little help, okay? Our focus today is on multiplication and division. Last week we talked about addition and subtraction. Someone who was here, could you define for the rest of the room what we learned addition meant? You don't want me to call on you. Somebody better volunteer. I'm sorry? Sure. What does addition mean? What is the definition of addition without using the word add or plus? Yes, putting things together, putting parts together. Okay, we learned everybody loves it because it has one and only one meaning. Subtraction becomes more complicated because we realize it has 3 different types of questions. It can be a comparison, a difference, or a separation of a part from the whole. Today we're going to focus on multiplication and division. If you were to just brainstorm for me what multiplication means to you, what are words that pop in your head? What's one word that pops in your head? I'm sorry? Product, okay. Somebody else said something. Repetition. Anything else? Combining. Combining what? Groups. So could I use multiplication to combine all the groups that are table sets in this room right now? Look carefully. Why not? There's different size groups. So multiplication means I'm combining same size groups, equal size groups. Okay, so when I'm thinking about that, if I'm combining equal size groups, I need to have some strategies at hand, especially if I'm 3rd grade and I haven't had an opportunity to build automaticity with the facts yet. I'm just trying to figure out what is going on. Usually children are very excited when they realize that when they have a factor of 1, oh, this is absolutely amazing. And it's such an important idea though. And I think sometimes we don't realize how unique 1 is and its special properties. But it becomes very powerful, especially as I start looking at moving towards Algebra 1, Algebra 2, Calculus, because so many times I need to try to create or compose a value of 1. It's an identity property for multiplication and division. And if it's big enough to get its own property in math, I can count on it always, always, always being the same no matter what number system I'm using. That means there's a lot of power there. So at your table, you have what are called place value blocks. Would you please take some out, become familiar with what's in the box, talk to each other, and then once you're familiar, we'll have a task. Thank you. Good job. So everybody had a chance to familiarize yourself. Did you notice something about these tools? What's one thing you noticed? They are 100. Okay. How do you know they're 100?
It's 10 across and 10 down, and I multiply.
10 across, 10 down, and you multiply because you had 10 groups of 10?
Yes.
Okay, so you're counting each individual unit as having a value of 1.
Correct.
Correct. Okay. So she has defined this small cube to have a value of 1. And she is telling me that this is how many times greater in area? 100 times greater. It is how many times bigger than this rod? 10 times greater than this rod. So can multiplication be used to compare then? Sounds like it. Oh my goodness. Look at the power of 10. Look at how the unit changes when I increase the size of this little cube by 1 power of 10. When I increase the size of this cube by 2 powers of 10. Which one would have this cube being increased by 3 powers of 10? Some of you have it and some of you don't. Go ahead. Oh, I see it. Look at that. Do y'all see it? The thousands cube. You built a thousands cube. You just knew where I was going with this. Okay. So that's wonderful. And that's powerful. And I'm excited about that because our place value system is built upon powers of 10. If I were teaching you binary code, we would be talking about powers of 2. If you lived in ancient Babylonia, we would be talking about powers of 60. Wow. Okay. So if I define this to have a value of 1. These are variables. What do I mean by a variable? It can change value. It is able to vary in value. Variable. If I define this to have a value of 1, what would be the value of the small cube? 1/10. Now what is the value of this square? 10. Now what is the value of the big cube? 100. Wow. This has a value of 1. At your table, discuss the value of all the other cubes. Thank you for letting me borrow. When you sit close by, I keep taking your things.
One 100. One 1,000.
Wow.
I think.
That's right. It is. But you think about
Yeah.
this. If this is 1, and I'm at the gas station, okay, let's talk the price per gallon. Let's talk the price per gallon. Where do I see this in the price per gallon?
In the cents change.
And how do they record this in the cents, in the change?
In the tenths position.
Is this in the tens position? How do they, does the gas price have a thousands position? You're not sure? We'll talk about that.
Well, I guess maybe, but it rounds.
That it rounds? Okay.
And the whole cube is 1.
The whole cube is 1. So I see right there, if I count these, how much would that be worth? 1/10. So how many do you have?
3/10.
3/10. Okay. All right. 1, 2, 3. Eyes on me. I asked a question at this table. And I said, I'm thinking of using these blocks to represent the price per gallon of gas. And I asked if the cubes that y'all started with is now 1, the big cube now has a value of 1, do we see this cube anywhere in the price per gallon? Not what?
The thousands spot?
We don't have the thousands on the gas prices.
Oh, no.
In Texas, where we have a lot of oil, I see something that looks like this. What's this about? What does that mean? Besides the oil companies trying to get just one more penny out of you, what does it mean? The government's trying to get one more penny out of you. You're right. Yes, it's probably part of the taxes. But what does this mean? 9/10 of a cent. 9/10 of a penny. If I have 9/10 of a penny, 9/10 of a cent, and these are my pennies, what place value does this have then? Thousands. Remember, our place value system is powers of 10. Every time I move one place value to the right, what am I doing with that power of 10? It's getting smaller. When I did this, what did I do with my powers of 10? What did we say about the size of the blocks? They increased by a power of 10, and several people said, I multiplied by 10. It got 10 times bigger. The tens are 10 times bigger than the hundreds. The whole number, 1, is 10 times bigger than the tenths. So if I go the other direction, what's the inverse of multiplying by a power of 10? Dividing by a power of 10. I divided by a power of 10. This is a tenth as big as 9 pennies. So your gas prices have thousandths values. It's just not written totally in place value form. They're trying to give you a little fractional piece of a penny. Okay, I would like you to take the blocks. We are going to let this have a value of 10. And I would like you to please build for me 4 groups of 10. I need you to have it organized. A pile does not help me keep track of my thinking, so I need it organized. Four groups of 10. Columns supporting a portico. So that's great, it was organized. Most of you chose to do 4 tens that look like this, or so that I could see doubles. Somebody did not have enough tools, but she knew she could still build 40. Could you please share with us how you built 40? She did not have enough 10 rods. Some people at her table did not want to share. So she built this with 2 10s and 20 1s. Does that still have a value of 40? Yes. If I am having to purchase something at the grocery store or at Best Buy, and I go in And I know most of you don't carry cash, but my husband's old school, so it's all cash. He may not have exactly the number of $10 bills he needs. Does that mean he cannot still pay for his product? Yeah, I can use other types of, other denominations of money. Okay, so y'all had a very organized structure. That's very exciting. At your table, you have grid paper. I want you, hopefully there's 2 pieces of grid paper at each table. See if there are. Okay, if you all could, half the table work on one piece, half the table work on the other piece. Here is your task. I need you to please build an array. Does everybody know what an array is? What's an array? Rows and columns. Organized. I need to see the groups. Mathematically, where did mathematicians agree that we would see the groups in an array? Do you all know that mathematicians agree to that? Okay, so let's talk a little bit about the history of math. There was a time we did not have easy access to each other. And when we look at what was happening right before the Renaissance and during the Renaissance, a lot of mathematicians were making huge breakthroughs. They started trying to communicate with each other and sending messages. But you might not have used the same symbols I was using, because I might not have had other mathematicians in my area to work with, or the mathematicians in my area all agreed to the same symbols. We had to come to some kind of agreement on which symbols we were going to use to represent certain mathematical principles, or we could not communicate with each other. I know a lot of people think mathematicians are just weird and trying to have this elite society, but there is a reason that is logical behind every single symbol. But we are people who value rules. We are people who value principles. So we all agreed that the groups would be held in the rows. And that the columns would hold the number of items per group. And this is true all the way through matrices. So this is going to be true forevermore. When you're doing computer program, it is rows by columns, always. And we all came to that agreement, okay? So when you build your rows, you're building your groups. When you're building your columns, you're building the number of items in each group. Everybody okay? Go ahead and draw.
We're using markers or based on block?
We're drawing now. Use your markers.
So of groups and columns, what do we need to draw?
So 2 groups
You're
of 3.
building 12 groups of 3. So I need you to decide, is the 12 the number of rows or is 12 the number of columns?
So it's rows, because it's groups. Rows, so cross.
That's right. I'm sorry, did I block you?
I'm trying to figure this out. So if you have 2 groups of 3, then you have 2 rows,
That's right.
and in each column,
In
you
each
have
row, you have 3 columns.
3 columns, not 3 things in
Oh.
each column.
Well, no, because your rows are holding it. So you have your 2 rows.
You can't have more than 1 per column.
That's right.
Only 1.
Okay.
No
Well,
more than
the
one.
columns and the rows together create squares.
Right.
That's where the square units come from for multiplication.
But isn't there an infinity inside of the 1?
Yeah, but I'm not counting fractions right now. I'm only
Okay.
counting whole numbers right
Okay.
now. But good question. Nice. Excellent. Good job. So how many rows will you need? 12 rows.
How many
How-
in each row?
3 in each
3
row.
columns. 12 rows.
Some parents start by making 12 across, and then they fill in underneath. Is
So
that
no one
making-
did? Was it perspective, though, from somebody
Maybe.
they were working next to? Because I saw that happen,
Maybe.
and the person drawing did it for their perspective, but not the person next to them.
Maybe.
I don't know. We'll see. So how many rows? That's right. You have 12 rows.
Right.
All right. So you have 1, 2, 3.
Right.
Sorry, I was trying to hold it for you. Great. And can you label this 12? And there you go. Thank you. Excellent. Great. Okay. That's right. Perfect. So what is this dimension? How long is this length? 12. So let's put a 12 right here. What is this dimension, this length? Good. Excellent. All right. So I see one, two, three, eyes on me. Thank you. Everybody did a thorough job. It was interesting listening to the conversations as everybody kind of laid this out. There is always a geometric structure associated with every mathematical operation. How many rows did you have? 12. How many items were in each row? 3. And so some of you actually marked very clearly the 3 columns. How many total items, how many total squares were within this rectangular array? 36. So if I record this, somebody earlier said I think of products when I think of multiplication. What's one way to read this?
3 dozen.
3 dozen. Thank you, sir. Giving me a context. All right. 3 dozen means I have 36 donuts. What's another way to read this? Y'all take a chance. Nobody's going to hurt you. Thank you. 12 groups of 3. 12 by 3. Every factor is a dimension. What's a dimension? A measurement. A measurement of length. This is a 2-dimensional figure. I have the vertical dimension. You might see it as the height. I have a horizontal dimension. You might see it as the width, the base, depending upon how you're sitting at the table. So I have 12 groups of 3, or 12 by 3. The reason it matters is because if you go to order blinds from JCPenney's or Sears, on the order form, they tell you, look at your window. You must give us this measurement first and this measurement second. and they will not give you your money back if you make a mistake. You will have blinds hanging on the floor and only covering part of the window if you don't do it the way they want you to. Y'all okay with that? Okay, this wasn't so bad. Pretty easy. What if I had had something like this? Do you want to sit here? Yes, ma'am. Okay, I'm sorry. It is 57 being multiplied by 4. 57 being multiplied by 4. Do you want to sit here and draw square by square unit until you have all of the squares within 57 rows and 4 columns? No, it's not efficient. So I move from this closed array where when I'm learning math multiplication for the first time, and I can count every square to help myself, to what is called an open array. I'm going to think of this as being made up of 50 and 7, because I don't know my 57 facts. I don't need to know my 57 facts. So if I do that, I can create an open array, an open area model. And I am going to label this part 50 and this part 7. Why is this so small compared to the 50? Because 50 is so much bigger. It's about how much bigger? 7 times bigger. 7 times 7, 49. What do I label this? The 4, my second dimension, my second factor. I now have 2 partial areas. Why would I need 2 partial products? Yes, because I can't do it all at one time in my head. So I've got to be able to think of this as 50 by 4 and 7 by 4. What's 50 by 4? 200. You can do that mentally. What's 7 by 4? So what is your total product? 228. What is your total area? 228. I start here because I've got to get to the point that I can see this as a 50 by 4 being combined with a 7 by 4. Here's your 200. Here's your 28. Who knows the name of this property? The distributive property. Good job. Why is it so important they learn it with whole numbers first? Yes. All too quickly, your children are going to be doing problems like this. And that is the distributive property. Right now, they may have 23 being multiplied by 42. But all too soon, that tens digit is going to be replaced with a variable. So I'm trying to understand the distributive property with numbers that make sense to me, so that as I keep moving forward, I don't freak out when I just say, I don't know how many tens we have. Let's just let it be any old variable. Y'all okay with that? Is this like what you learned in the old days? Okay. Tell me what you wanted to do.
7 times 4.
Which is what? 28. There's your first partial product. There it is right there. Go ahead. What do you still need to multiply?
The 5 and the 4.
Now, is this a 5?
Well, there's 5 10.
5 tens. So I have 4 groups of 5 tens, which really gives me what number? 200, or 20 tens. There's your 2 partial products. And there is your total product. Why do they need partial products? What do you see there that I didn't see when my teacher was teaching me in the late 50s? Yeah, she even told me, like, if I had 2-digit multipliers, we put a little goose egg down first, move over to the left. Yeah, I did it. She gave it to me 1,277 times until I knew that was what I was supposed to do. But I didn't understand why I was doing it because she wasn't talking about place value. She wasn't helping me reason about the magnitude of the numbers. And God bless Miss Dutton, she probably didn't know herself either because that's how she had been taught. So we're trying to help math make sense because it is sensible. We are trying to keep them from being efficient, though. The problem is we don't always work with whole numbers. All I will ever do once I get to this is deal with partial products. And everything I'm doing is so that they don't see a disconnect between what I'm learning in secondary compared to what I learned in elementary. It's one and the same. The only thing that's changing is either the number system or the fact that we're using variables. Y'all okay with that?
I have a question real quick.
Yes.
I love the way I'm watching my son do this method of you're going to write. Of course, I line it right up like that, and he's like, I can't get this to work. I'm like, well, let me show you the way I know how to do it. There's the disconnect that he's totally getting this method, but when you have it lined up horizontally with the 200 plus the 28, say it's more like 237 plus 24. He's not lining it up in this column form like we learned how to do, and he's making mistakes on the actual addition calculation.
Okay.
The multiplication part of breaking it down and all that is going great.
Okay.
The actual adding the 2 quotients or whatever they're called together to get the actual number is where the mistakes are happening.
Okay. So then I would probably have him go back, and you said 237.
I mean, something that's not as easy as 200 plus 28. I mean,
Okay, sure, that's okay. So he's doing this plus 54, I think you said, or something. Okay, all right. So is he trying to do it horizontally, or is he trying to line up like place values?
Okay, well, let's just make it even more realistic. So it was a big number, it's 1,235 times 23 or something, I don't know. And so he broke it down into the thousands, the 200s. So he's got 4 and 5 lines in going, okay, to get this, and he has to add up these 3, 4, 5 numbers to get the final quotient. So one of the numbers is up here, the other one is down here.
So it's organization.
Correct. So he's
Okay.
not bringing them.
Okay.
He's not bringing those down and starting a whole addition setup.
Okay, so then what we need to help him on is the nesting, why I have to have it organized so I can keep track of my like place values,
Okay.
my like terms.
Because when they're
So-
kind of written up here. written
Right.
up here,
And organization is a big deal. The teachers will tell you, I will go in the room and tell the child, I just walked in the room, I need you to help me. And it's so disorganized, your work is not standing alone. What if you weren't here to explain it to me? What would I do? And usually, because these children are so sweet, they're like, oh, well, I'll help you. And they immediately start to organize. Then I sit back and talk about why was that organization so important for yourself? How does it allow you to prevent errors? It is a process. It isn't an event. It takes time to learn how to organize. So our job then is to help him, and I would probably suggest that we give him grid paper, and so I need to see every single place value lined up perfectly so that I know you know where are the thousands, the hundreds, the tens, the ones.
Okay.
And that would be a good first step.
It would also be helpful to be able to take the tests with the graph paper.
Absolutely.
Because the area to be able to execute the test is just this sort of blank white paper area.
Okay, so then we
the
need to
numbers are
tell.
little, then they get bigger, and then he's got these different numbers.
Okay,
and
so organization
error,
again.
error.
So what we can do is tell him that he needs to take advantage of all the different tools that are available in the classroom. Go over, grab that grid paper, and we need to help the teacher encourage that first before he takes ownership of it. Because you're right, it makes a difference. And do you know that now most of the assessments children see provide them grid paper? Because it is a tool. It's a powerful tool. It is a powerful tool. Okay, yes, ma'am.
Aren't the kids being taught to think through it horizontally, though? When I tell my daughter, let's line it up, she doesn't know. She's like, no, that's not how we do it.
Okay, well, they should be able to operate both ways.
Okay.
But the algebraic thinking that is captured in operating horizontally is what she's going to have to be able to do as she continues. So if you look at, here's something that's happening in the 6th grade right now. If I see that and I'm trying to line things up, I'm in a mess really fast. So the reason we line it up is to help us track place value. It allows us a means to efficiently grab all those like terms. But at the same time, that is a powerful tool, and I want them to be able to do that. But I also need them to think about estimations, reasonableness. Where do you see those like place values? And then help them go back and forth.
Okay.
And so
Being able
they're
to go back
young,
and forth.
and they're trying to get there. It's just taking a little time for them to get there. Okay, so along those lines, we've talked about multiplication. On your paper, I'd like you to please help me solve a problem. Miss Clifford purchased 136 books. She needs to divide them equally among 4 teachers. 4 teachers are going to share these books. I would like you to please build with the place value blocks each teacher share.
They all wanted to do traditional division there.
I know. Everybody grabbed paper and pencils and they wanted to crunch numbers.
I just wanted to ask a follow-up question on what you were illustrating there. I understand, the stuff you had on the right, it sort of shows them the intuition of the parts. But a technique like that, it's not scalable, right? So doing it on the left, the way, like with all the columns, that's something that, it's something that you can easily do. Like you can do 57 times 4, the technique on the right works well, but if you have 57 times 23, you really got to use that technique on the left. Right.
No, ma'am. The other day in Mr. Hendry's class, when they were given a factor of 23, all the children multiplied a 3-digit number by 25 and then subtracted 2 groups of that number. And I asked, how can you do that? I know my 25s because they're quarters.
Right.
I can double forever.
Okay, but my intuition is that the technique on the right, even though it's better for someone who might be like a visual thinker, there's also like more moving parts, more room for error. And so I'm thinking about when you're in a standardized test situation where you don't have time, to be graphing that out, doesn't the approach on the left work better?
It depends on the child because 67% of us are visual learners.
Oh, so if you're more dominant in the visual, then you're better off with that. And you will probably be
more
less
successful
likely to
there.
make mistakes.
Right. Because
Okay.
yes, and I will tell you, I was so well trained, it was hard for me to transition, but now I realize how efficient it allows me to be. So now I'm able to take those values, I'm able to deal with factors that are not just single digits even, or look for relationships like his students did. And he and I were both caught off guard at their number 6. We didn't realize they were going to think of 23 as 25 minus 2.
Yeah.
And it kind of caught us off guard because we were trying to get them to buy into using the columns and the double digit and the value of partial quotients. So we had to change the numbers we were using so that they couldn't take advantage of their number 6.
But at Mount Vernon, they're being taught both ways.
Yes, they're being taught both ways.
But then are they allowed to, if they then realize they're more, like if one approach is faster for them than the other, you just let them?
You're supposed to make a decision about which way will you be more efficient.
Got it.
And that too is a process. I have to think about, okay, how can I be more efficient and accurate? Those are 2 huge hallmarks
Okay.
of developing mathematics.
Okay, that helps.
Does that help?
Yeah,
But he and I
so
had to
basically-
really choose numbers so they would buy into partial products because they were whipping these things out, and we were like,
Yeah.
okay, wait,
Yeah.
let us come up with another number so you can't do that.
Okay, that makes sense.
Nice job. Okay. So, where is one teacher's books? So you only have this one share. This is the number of books per teacher. So it's a rate. Is it a rate? Number of books?
The actual in question. What was the
Okay.
in question?
How many books will one teacher receive?
We didn't get that part. Okay.
Okay. So it looks to me like you almost created force.
We represented the total, I guess.
Did
That's
you
what we saw up there.
Right, but did you create force?
Yes.
So you took a fourth of the number of books? So when we divide by 4, am I always taking a fractional part?
Yeah, you're taking a fourth at a time.
Every time? He's saying that when I divide anything by 4, it's the same as taking 1/4 of the group. Yes? So if I divide by 5, that's the same as taking 1/5 of a group. If I'm taking 1/8 of a group, it is the same as dividing by 8. So are fractions and division synonymous with each other? Yes. Okay, I like that. Look at you. Keeping your rectangular array. That is so cool. Nice job. multiplication. Okay, so I would like to talk about what I saw at two different teams. I saw one group build 4 tens, and then, is this what you built? No, you built 3 tens and 4 ones. I'm sorry, I was looking over your shoulder. 3 tens and 4 ones. And they built it 4 times. Why were they separating the books into 4 different groups of equal size? Because there were 4 teachers. So just like multiplication meant I was combining equal size groups, what does division mean? I am separating into equal size groups. So they had the 136 books divided into 4 equal groups. What question did I ask you all? Do you remember the question I asked y'all? Okay. And then I said to you, it looks to me like you created force. Did they create force? Yeah. So every time I divide, am I creating a fair share? Yes. Every time I divide, am I looking for a fractional part of the whole group? Yes. And this time, I know this dimension. I know the 136 books. What am I looking for? Books per teacher. The books per teacher, this missing factor, this missing dimension. I want y'all to watch. Because there was a time in history, these were the only ways we represented division. And then something funny happened.
There's the house.
Oh, the house, the house. It's an area model. And when people were trying to seek efficiency, they removed 1 length and 1 width from the area model to get the house division sign. So they could easily separate partial groups, partial quotients. This is the area model. You just didn't know it. Wow. Okay, looking at this, this is what I was told. This was not Miss Dutton, this was Miss Toops. You are not going to say this is 100. You're going to cover up these digits and you're going to say, can you divide 1 by 4? And you say no. But then 3 weeks later, she said, you can divide 1 by 4, it's a 4th. And I was so confused. How many groups of 4 could you easily build? How many books could you easily give to each teacher right off the bat? And what did they do? 30. So I am going to build 30 groups of 4. And I'm going to keep track of these partial quotients right here. 30 groups of books, 30 books to 4 teachers. How many books did I just sort? 120. Now, you were probably told not to put that 0 there, but it really was 120. How many books are still left to be sorted? 16. How many books per teacher will that be? 4 books per teacher. 4 group books to every single teacher means I sorted the last 16 books. What is my total quotient? 34 books per teacher. My unit rate. The number of books in one of 4 equal groups. So all we're asking is that the students attend to the magnitude of a number. So at the end, I'm not saying, does your answer make sense? And they're shrugging their shoulders at me because I kept changing this from 1 to 10 to 100. No, it's 120. No, it's 12. We are keeping the values of the numbers consistent all the way throughout. So there won't be this confusion. Y'all okay with that idea? Kinda? Yes, ma'am.
Can you get back again and how you got the 30?
Sure. I think what they knew was that when they built did y'all start with the 30 or the 20? Like when you started building this. Oh, you did 10. And so you said, okay, so they did 10 groups of books, that was 40. Another 10 books of 4, that was now 80. Another 10 books for the 4 teachers, so now they were at 120. So they used powers of 10 to help them. Now, what I would have done is I would have said, I need a multiple of 4 that is going to get me close to 130, or 13 tenths. If I think of this as 13 tenths, I have a nice fat because I know I can, 120, 12 tenths is a multiple of 4. Okay? So you use facts that you know, facts that are friendly for you. Okay? And those powers of 10 is where we usually start because, especially if they haven't learned all their facts yet, I've got to start with something I know they can handle.
I was just thinking in terms of how to help a child.
Sure. So we might say, could you build 10 books of 4, 100 books of 4, and give them at least a starting point?
So are you saying to guesstimate first and then kind of try to fill in the pieces to be more accurate?
Yes. So a lot of times, Chip, a child will tell me, well, I know I can build 10 books of 4. I mean, yeah, four groups of 10 books. Okay, that's fine. Could you double that? Oh, yes, I can double. I know you can double. Good. Oh, I could build 20 books of 4. Okay. How many books is that? 80. And if I think that's really all they can do right now because it's early days, I'll let them start with the 20. If I start, I'm so sorry. That's okay. If I redid this.
There's a camera on your phone, probably.
What's 20? What's 20 groups of 4? 80. How many books are left to be sorted? 56. How many books can you give to each teacher? If there's 56 books, how many do you know you can hand out? 10 more? 10 books to 4 teachers each? 40 books? Do I still have 34 books per teacher? Oops. Now, is this as efficient? Well, it's not for me because I know my facts. If I don't know my facts, it may be more efficient than me sitting here counting on my fingers or drawing 136 tally marks or something like that. And I will tell you, I have a sister, and God bless her, I love her to death. But to this day, her 7, 8s, and 9s are pitiful. Now, I mean, she has her own practice in Houston. She is if you count success as money, which we don't, but if you did, she's wildly more successful than I am. But she doesn't know her 7, 8s, and 9s. We go into a store, and she'll say, so how much am I going to have to pay? And she counts on me to tell her how much money she's going to need so she knows she's not exceeding her budget. I said, when I'm not with you, what do you do? She said, well, I get Cole to do it. Cole's her son. She's scared to death because she never could figure out how to learn the 7, 8s, and 9s. So a few years ago, I said, Kendall, just stop a minute. 9 groups of 6. Do you know 10 times 6? Well, of course, it's 60. I said, well, you just need one less group of 6. She said, all I had to do was subtract 6 from 60? And I said, yes. And she said, well, then I can do 9 times 6. I said, yes, you can. And she said, well, don't tell me the other ways yet. Let me learn that one. I don't know what facts everybody's bringing to the table. Facts allow me to be efficient, and that is important because I don't want to get so caught up in how do I find the product that I lose track of the big problem I'm trying to solve. But just because you don't know a fact does not mean you cannot find the solution. It just means you may not find it as efficiently as somebody else. Does that help a little bit to clarify? Okay, yes, ma'am. Time? All right. I don't have time to go to everybody like I did last week, but could some people please raise their hand and tell me something that you've realized in our time together?
There's multiple ways to do, like I did 136, I thought of 100 and then 36.
There you go. So you saw 4 quarters, 4 shares, and you knew 100 divided by 4 was 25. Look at there. You could even do it in your head then if you know that. Okay, so multiple ways to tackle a problem. Anything else?
Well, I like the history lesson and the importance of the uniformity of symbols and agreeing on certain things. So,
And you, former social studies teacher, I bet you
trying
do.
to do this without the same symbols. That's crazy.
It would be crazy. All right, what else?
To me, when you said you're doing this algebraically, you're bringing that from whatever grade it used to be down to when you start. That was a huge key for me to understand how you guys are going to teach.
Okay, because we don't want them to freak when they get to Algebra 1, or
Yeah.
we want them to say,
You're not labeling it as algebra, but it is.
yes, you're right, it is. Thank you. Anything else?
Will they eventually be able to use whatever works for them?
Yes. All right, so
Once they've learned all this, when they're in high school, will they be like, you know what, this works better for me, or this works better for me, and then they can get it, so it's not like they have to do it this way or have to do it that way?
no, that's right. They will have various strategies. And mathematicians, especially if they apply it in their jobs, do not just start crunching numbers. We actually hesitate and we think about, okay, look at the numbers that are being used. What will allow you to be most efficient and most accurate? And then we make that decision, then create an estimate before we actually calculate. And if it is so nasty that I'm worried about my accuracy, I'm pulling out an Excel document, I'm going to use an Access program, I'm going to grab a calculator to confirm my work, because it may be that I'm Otis and you care if that elevator doesn't work. It might be that I am trying to make sure that the bridge has this structure still in place so that the cars won't collapse. It matters how accurate we are. And I have to determine, is it more important that I'm efficient or more accurate in this situation?
But sometimes a person's brain works a certain way, like my children may be like more like pen on paper, actually see it, where another person's in their head, so I just.
Right.
know that-
Yes, everybody has a different level of mental math, but Americans traditionally use paper and pencil more than any other country in the world, because nobody gave us time to develop the number sense. Nobody gave us time to establish relationships. Austin, Texas is the capital. And one day during lunch, they went out to the intersection of Capitol and 6th Street. And I don't know if you know anything about Austin, but 6th Street is like the happening place. And they interviewed as many people as they could from noon to 1 o'clock. And they asked them an addition problem, subtraction problem, multiplication problem, division problem, never more than 2 digits. They were taking out pencil and paper, and if they were denied pencil and paper, they could not find the answers. Now that is scary. So we have got to help them become more globally competitive. And it's not just saying it's about getting to a numerical answer. It's about having relationships so that I can tackle whatever I need to tackle when I'm confronted with it. I mean, my husband grew up on a farm. And half of the acreage was farm and half of the acreage was a feedlot. And we get married. I have 2 degrees. One of them is mathematics. And we're listening to the AM weather report, which became a huge part of my life. I want you to know. I'm not married, but I know that. And we're sitting there, and we live on just north of the Rio Grande River. And so he does a lot of work on both sides of the border. And they are talking about all these Celsius temperatures. And so I'm trying to go through the formula in my head, and in less than 3 seconds, he's saying, oh, that's 89 degrees. Oh, that's 56 degrees. And I'm like, you are not the math person. How are you doing this? And he said, why are you trying to deal with the 5/9 and the 32? 5/9 is just about a half. 32 is 30. They're going to compensate for each other. So just deal with the half and the 30 and you're done. And I'm like, I can't believe he did this to me. That is the difference between having all these memorized facts and having real life application with number sense. And he was getting values that were perfectly appropriate for his circumstances and doing it in way less time than I was taking. And so we have to decide, is ballparking it appropriate or is accuracy that appropriate? And if it's that appropriate, should I be running these numbers through some other system to be sure? Because if the neurologist wants to operate on, the neurosurgeon wants to operate on my brain, he better have all kinds of data to prove to me that he's going to be accurate. Does that help a little? Okay. Anybody else?
I think I understood that for every numerical operation, there is a geometrical connection?
Yes.
Representation?
Yes, representation. And those relationships are powerful because 67% of us are visual learners.
I always thought geometry was a separate subject.
Never. Just like division and fractions are synonymous with each other.
I'm really glad to know why we're teaching arithmetic, well,
Yes.
addition and subtraction horizontally, because it's, when I'm helping my daughter with her homework, I don't have to say, that's wrong. Why are they, this is, I can support it and say, well, we need to separate that and do it vertically, but then bring it back to the horizontal
Absolutely.
picture, because we're going for algebra, we're
Right.
heading in that direction.
That's exactly right.
That's
and
great.
and I don't want you to be frustrated.
Yeah.
So if you want to go in and work with the teacher in practice, you can. If you want get some grid paper to help support that system, absolutely.
But then bring it back to
But
the
bring it
horizontal.
back so we know that there is that deep understanding of those place value relationships. Powers of 10. Okay, to help you, the school has some literature books, and I know some of the parents have already purchased them and are studying them. Look how thin it is. It's not heavy reading, even though somebody said she had to do it on a plane. And one of them is number sense, addition, subtraction. One is multiplication and division. Did you get the green one? No, okay. Next time you come, we'll do fractions. Okay. And we'll let you have that. But if you are interested in how can I help my child, what are other relationships that we could not cover in an hour, you are more than welcome to head for that table. And I thank you so much for your time and enthusiasm and questions. You all were fantastic. Hi.
Hi, Mona.
Hi, Morna. I'm Garland. It's nice to meet you.
Garland, I want to ask you. I grew up in a different country in Egypt, and we apply the French system in mathematics.
Yes.
So I want to ask you something.
Yes.
It will make, for me, maybe it will be easier. When you have the 136, say, okay, you said we cannot, for them, if this number is less than,
For
cannot
the
be,
divisor.
can be divided, yes. So I start here, like the first two digits, and 4 is 12, so it will be 1 and 6, and then 4
But that's
and
not
16.
really one.
I know, so it's 10, Yeah, it's come down, and then I add
Yeah,
the second
but
digit
then we've
here.
lost place value. We've lost place value. We've lost place value. We don't have reasonableness anymore. Like even France is converting to all of this.
No, I cannot hear you from
Okay,
there.
I know. It's hard to hear over everything.
Tell me that again.
It's okay if I get closer to your ear?
Yes, yes.
Okay. What we want is them to hang on to the magnitude of this number.
Okay.
To understand how big it is so they have a reasonable estimate. All of the countries are shifting to never letting place value go.
Okay.
In fact, France has rewritten their curriculum to make
Of
sure
course,
that.
this is long time ago.
Okay,
yeah.
no, I know, me too. I mean, because I didn't learn this way either.
Okay.
I learned the way you learned it. But then when I had got into higher mathematics, all of a sudden all these flaws erupted because I wasn't attending to the magnitude of the numbers.
Okay.
I wasn't thinking
But
about
it's the same
size.
idea. You're breaking the magnitude of the number.
And as long as I can think of this as 13 tenths,
Yes.
then I'm okay. But if I say that's 13, it's not 13.
No, I mean you start with two digits.
Okay.
You cannot do that.
That's right. But that's why the place value is so important, so that I know that I'm not making an error.
Oh, so you put the zero under the
Yes, because
the
that's
units
really
on the set.
120, right?
Okay.
Right? And I'm subtracting a 3-digit number from a 3-digit number. Just like that mother said, the child is moving the columns.
Exactly.
I don't want the child moving the columns. I want them to see that there's 0 ones here. And 6 minus 0 is 6.
It's 6.
And 13 minus 12 is 110.
Yes. Okay.
Does that help?
So you put zero under the unit, but you keep the
Because
tens.
of, yes,
Okay.
that's right, to keep the
Yes.
place.
All
But
right.
you're hearing two mothers are having an issue with their child
Yes. And
tracking place value.
I'm so glad you enforced the rough paper because last year
Yes.
I attended your class for the
Oh,
second
good.
grade.
Did it help?
It helped, but I had one remark. It was great, the presentation. But you said last year you have to suffer a little to get it.
Grow there. Growing pains.
When you suffer doing math at a young age, you will hate it forever. I was very good at
Okay.
math. And I
Okay.
saw that. I want you to know that for the system here. Yes, my son is very good at math.
Good. I'm happy to hear that.
All right? But doing IXL, it was such a frustration to the whole house.
Okay.